Neptune, a giant of ice and gas, reigns in the cold, dark depths of our solar system. It is the eighth planet from the Sun, far beyond Saturn's rings. This blue world, named for the Roman god of the sea, remained hidden from ancient astronomers. Unlike its brighter neighbors, Neptune was too faint to be seen with the naked eye. It wasn't until 1846 that Neptune was discovered, not by observation, but by mathematical prediction. Astronomers noticed irregularities in the orbit of Uranus and deduced that an unseen giant must be gravitationally tugging on it. Neptune is a planet of extremes, with supersonic winds and immense storms. This distant world, cloaked in blue, holds many secrets waiting to be unlocked. Neptune's gravitational domain extends far beyond its swirling clouds. It shepherds a diverse collection of 14 known moons, each with its own unique characteristics. Triton, Neptune's largest moon, is a world of icy volcanoes and nitrogen geysers. It orbits Neptune in the opposite direction to the planet's rotation, suggesting it was captured by Neptune's gravity long ago. Among these moons, Proteus stands out with its irregular potato-like shape. Discovered in 1989 by Voyager 2, Proteus surprised scientists with its dark, ancient surface. Orbiting Neptune at a distance of approximately 117,600 kilometers, Proteus completes one orbit every 27 hours. This proximity to Neptune, combined with its dark surface, made it a challenging target for Earth-based telescopes. Proteus wasn't a pristine, icy world, but a heavily cratered, charcoal-dark object. Its most prominent feature is Pharos, a massive impact crater that dominates one side of the Moon. Scientists believe its darkness may be due to complex organic compounds, offering clues to the early solar system's composition. Few missions have been as groundbreaking as Voyager 2. Launched in 1977, this robotic explorer sent back stunning images and invaluable data that revolutionized our understanding of the giant planets. Voyager 2's encounter with Neptune in 1989 was a pivotal moment in planetary science. The spacecraft's cameras captured the azure hues of Neptune's atmosphere, revealing its turbulent nature and massive storms. Voyager 2 detected 6 new moons orbiting Neptune, including Proteus. The flyby provided a treasure trove of data that continues to fuel scientific inquiry to this day. The discovery of Proteus was a serendipitous find, a testament to the element of surprise in space exploration. On August 16, 1989, just days before its closest approach to Neptune, Voyager 2 captured images revealing a faint object moving against the backdrop of stars. This object, initially designated as S1989N1, was confirmed to be a new moon of Neptune. The discovery highlighted the importance of space exploration, revealing that even in well-studied systems like Neptune's, there were still surprises waiting to be uncovered. The name Proteus, after the shape-shifting sea god of Greek mythology, was officially adopted for the new moon. Proteus is a world of stark contrasts, a dark and ancient body set against Neptune's azure brilliance. With a mean radius of about 210 kilometers, it is Neptune's second largest moon, but its most striking feature is its irregular non-spherical shape. Proteus's surface is heavily cratered, bearing the scars of countless impacts from asteroids and comets. The moon's dark surface, reflecting only about 6% of the sunlight, adds to its enigmatic aura. These complex organic molecules may represent the building blocks of life and provide clues about the conditions under which life arose in our solar system. Among the many craters that scar Proteus's surface, one stands out: Pharos. This impact crater spans nearly half the width of Proteus itself, with a central peak rising from its floor. The crater's rim is irregular and heavily eroded, suggesting billions of years of impacts. The size and morphology of Pharos indicate a significant impact event, likely involving an object several kilometers in diameter. Pharos serves as a stark reminder of the dynamic nature of our solar system, telling a story of cosmic violence and ancient impacts. Proteus circles Neptune at a distance of about 117,600 kilometers, locked in synchronous rotation. This cosmic dance, a consequence of tidal forces exerted by Neptune, dictates that Proteus's day is equal to its orbital period. It takes roughly 27 hours for Proteus to complete one orbit around Neptune. Proteus follows a nearly circular path around Neptune, suggesting a relatively stable orbital evolution. This shared origin connects Proteus to the other Neptunian moons, weaving them together in a celestial tapestry of shared history. One of the most striking features of Proteus is its extremely dark surface, reflecting a mere 6% of the sunlight. This makes it one of the least reflective objects in our solar system. One prevailing theory suggests that its surface is covered in a layer of organic compounds, possibly rich in carbon and nitrogen. These compounds, delivered by comets and asteroids, could darken the surface over time. Future missions might analyze Proteus's surface in greater detail, shedding light on this enigmatic characteristic. Despite its location in the frigid outer solar system, Proteus seems to lack significant water ice deposits. One theory is that Proteus formed closer to Neptune and later migrated outward, losing its ice content due to the sun's heat. Another possibility is that intense bombardment early in its history vaporized any surface ice. Understanding the distribution of water ice in the outer solar system is crucial for unraveling the processes that shaped this region. Proteus is thought to have formed from the remnants of the disk of gas and dust that once surrounded the young Neptune. This process, known as accretion, involved the gradual accumulation of smaller particles into larger bodies. Proteus's irregular shape suggests it never grew large enough for its gravity to pull it into a spherical form. The heavily cratered surface points to a violent early history, with intense bombardment by asteroids and comets. Studying Proteus provides a window into the chaotic early days of our solar system. Proteus stands out for its unusually dark and ancient surface. Scientists believe the moon's surface is covered in a complex mixture of organic compounds delivered by comets and asteroids. These compounds, rich in carbon, are highly effective at absorbing sunlight, explaining Proteus's low reflectivity. The presence of these organic molecules is intriguing because they are considered the building blocks of life. Studying their composition on Proteus could provide valuable insights into the conditions under which life might have arisen in our solar system. Section 2. Cratering History, Unraveling a Violent Past. The surface of Proteus is a testament to the violent early history of our solar system. It is heavily cratered, pockmarked with impact scars of all sizes, a testament to a time when the young solar system was a chaotic shooting gallery. These craters vary in size from small bowl-shaped depressions to large complex structures with central peaks and terraced rims. The sheer number and diversity of craters suggest that Proteus has been subjected to impacts from objects ranging in size from small pebbles to larger bodies, perhaps kilometers across. By studying the size, distribution, and morphology of these craters, scientists can piece together a history of the bombardment that Proteus has endured. This cratering record provides valuable clues about the types and sizes of objects that were present in the early solar system, as well as the frequency and intensity of impacts. Furthermore, the cratering patterns on Proteus can be compared to those found on other moons and planets, allowing scientists to understand the relative bombardment histories of different bodies in the solar system. This comparative planetology approach helps to unravel the dynamics of the early solar system and the processes that shape the worlds we see today. Section 3. Compositional Clues. What lies beneath Proteus's surface? While the surface of Proteus reveals a great deal about its violent past, the Moon's interior remains largely a mystery. Scientists believe that it is likely composed primarily of a mixture of rock and ice, but the exact proportions and distribution of these materials are unknown. The lack of a substantial atmosphere and the absence of any detectable geological activity make it difficult to probe beneath Proteus's surface. However, scientists can make some inferences based on its density, which is slightly higher than that of water ice. This suggests that the Moon must contain a significant fraction of denser material, such as rock. One possibility is that Proteus has a differentiated interior, with a denser rocky core surrounded by a mantle of water ice. The relative proportions of rock and ice would influence the Moon's overall density and could provide clues about its formation and evolution. Future missions to Proteus, equipped with instruments capable of probing beneath its surface, could provide more definitive answers about its internal structure and composition. Such missions could use techniques like radar sounding or gravity mapping to determine the thickness and composition of its different layers. Section 4. The Proteus Puzzle, Unanswered Questions and Future Exploration. Despite Voyager 2's insights, Proteus remains a mystery. Key questions about its dark surface and internal structure persist. Future missions could reveal Proteus's secrets. Until then, it remains a silent sentinel in the outer solar system. Section 1. A Family Portrait. Neptune's Diverse Moons. Neptune's realm extends far beyond its swirling blue atmosphere, encompassing a diverse family of 14 known moons. Each of these icy companions holds its own story, shaped by the giant planet's gravitational pull and the tumultuous history of the outer solar system. There's Triton, the largest and most enigmatic, with its retrograde orbit and icy volcanoes. Nereid, with its highly eccentric path, hints at a past encounter that flung it into its current chaotic dance. Larissa, with its heavily cratered surface, tells a tale of ancient impacts. And then there's Proteus, the second largest, a shadowy, angular world that stands out even among its unusual siblings. This diverse collection of moons provides a rich tapestry for scientific study. Their varied sizes, shapes, surface features, and orbital characteristics offer clues to the processes that govern the formation and evolution of the Neptunian system. By studying these moons, we gain insights into the dynamics of planetary systems, the interplay of gravity, and the role of impacts in shaping celestial bodies. Each moon, a piece in the puzzle, helps us to understand the broader picture of our solar system's history. Section 2. Proteus among its brethren, similarities and distinctions. Among its Neptunian siblings, Proteus occupies a unique position, straddling the line between small, irregularly shaped moons and larger, more spherical bodies. Its size, larger than Saturn's moon Mimas, sets it apart from the smaller, irregularly shaped moons like Despina and Galatea. However, unlike its larger spherical counterparts like Triton, Proteus retains its irregular, potato-like shape, a sign that its internal forces haven't overcome the rigidity of its composition. This characteristic links it to smaller moons like Nereid and Hippocamp, which also exhibit irregular forms. Proteus's surface, heavily cratered and extremely dark, further distinguishes it within the Neptunian family. While many icy moons possess relatively bright surfaces, reflecting a significant portion of sunlight, Proteus absorbs most of the light that reaches it, giving it an almost ghostly appearance. This dark surface, likely covered in a layer of organic compounds, sets Proteus apart from moons like Triton and Proteus, which exhibit brighter surfaces composed of ices. The origin and composition of this dark material remain key questions for scientists studying this enigmatic moon. Section 3. Triton, a world apart, yet intrinsically linked. While Proteus shares its orbital neighborhood with a diverse cast of moons, one stands out as a stark contrast. Triton, Neptune's largest moon and a world of captivating extremes. Triton's retrograde orbit, opposite to Neptune's rotation, suggests it was captured from the Kuiper Belt, a region of icy bodies beyond Neptune. Unlike Proteus's ancient, heavily cratered surface, Triton displays a surprisingly youthful visage. Its surface, sculpted by icy volcanism and nitrogen geysers, suggests ongoing geological activity, a rarity among celestial bodies in the outer solar system. Despite their stark contrasts, Triton and Proteus are intrinsically linked. Triton's arrival in the Neptunian system likely caused gravitational disruptions that affected the orbits of the other moons, potentially contributing to Proteus's current position and orbital characteristics. Furthermore, studying the similarities and differences between these two moons provides insights into the diverse processes that shape celestial bodies in the outer solar system. Triton's captured nature and active geology stand in stark contrast to Proteus's likely ancient origin and heavily cratered surface, highlighting the dynamic interplay of forces that have shaped this distant region. Section 4. The significance of comparative planetology. Lessons from Proteus. Comparative planetology helps us understand the solar system by studying celestial bodies' similarities and differences. Comparing Proteus to other moons reveals its unique traits and the processes that shaped it. Proteus's shape and surface offer clues about the early solar system and impact events. Studying Proteus within its cosmic family reveals the forces shaping planetary systems. As we gaze out at Neptune, our understanding of the universe deepens. Proteus stands out as a beacon of intrigue. No longer a mere point of light, Proteus reveals its secrets. Imagine a future mission, a dedicated spacecraft unlocking Proteus's secrets. This mission would be a journey back in time, understanding our solar system's origins. Proteus, with its unique characteristics, holds the key to unlocking scientific knowledge. Its dark surface, rich in organic molecules, could provide insights into the building blocks of life. Analyzing these compounds helps us understand early solar system chemistry and life's origins. Proteus's craters record the early solar system's bombardment phase, shaping planets and moons. Studying these craters helps reconstruct this violent period and understand cosmic forces. Proteus's shape and position offer insights into moon formation and evolution. Studying its dynamics refines our models of planetary system formation and moon diversity. Proteus represents a stepping stone for humanity's exploration of the cosmos. The outer solar system, with its icy moons and dwarf planets, beckons as a realm of immense potential. Proteus could serve as a base for future exploration of the Neptunian system. Its resources could support future missions, reducing the need to transport from Earth. Studying Proteus could inform technologies for exploring other icy worlds. The challenges of the outer solar system will drive innovation and push human ingenuity. Proteus is a gateway to a new era of exploration, symbolizing humanity's spirit of discovery. As we stand on the precipice of a new era in space exploration, our gaze extends beyond the familiar confines of our inner solar system, reaching out to the realm of giants, where gas giants and ice giants reign supreme. In this distant, enigmatic region, where the sun's light flickers faintly, a universe of discovery awaits. Proteus, a small moon orbiting a distant giant, serves as a reminder that even in the most remote corners of our cosmic neighborhood, wonders abound. It is a testament to the power of human curiosity, our relentless drive to explore, to understand, and to push the boundaries of what we thought possible. As we continue to develop new technologies, to design ever more ambitious missions, and to nurture the next generation of explorers, we can look to Proteus as a symbol of the boundless opportunities that await us in the cosmos. For in the realm of giants, where shadows dance and mysteries linger, the universe beckons us to unravel its secrets and to embrace the infinite possibilities that lie ahead.